Hello, this is our final presentation for Senior Design Project, Khazan 2 Re-Entry Prospects at Team 9. Our final project is going to discuss the project management plan and the next step towards the succession of this project. Khazan field is in Oman and has been explored by PDO and handed over to BP for development. Khazan 2 is an exploratory well drilled by PDO, and we are going to study the possibility of re-entering this well for further production. Some data has been gathered, and we're going to run a reservoir simulation model to be able to estimate possible rates of production, and then we're going to design a drilling program and estimate the cost and run some cost analysis to be able to determine whether it's feasible for us to re-enter the well or not. The objectives, activities, and deliverables of the project are going to be discussed through the project management plan, and the benefits and the project evaluation are going to be key inputs towards the succession of this project. The project management plan has been completed by all the team members and discusses the whole steps of the project from start to finish and the sequence of the success required for the completion of the project. It also discusses the scope and the project management approach, in addition to a few milestones that we need to get done with for the succession of this project.
As for the project management approach, we're going to study the well logs, fracture data, seismic data, drilling reports, and operational reports. Since the well has been fracked, we're going to use the fracking programs to get an insight of the porosity and the permeability resulted. Using the dual porosity and simulation program, this will give us an estimation of the production rate. Dr. Wesley Williams is going to supervise the project progress. Dr. Stephen Sears is going to help us define the production rate, which is our main goal in this project. Jonathan Knowles is going to help us define an appropriate re-entering methodology if needed. This slide shows each team member with their responsibility associated with this project.
The scope of our project includes the organization, analysis, and reservoir simulation of the data for the well. We will be focusing on three main factors: drilling, completions, and simulated production. We will be analyzing drilling reports, looking for problems of any type that might impede our re-entry into the well, such as a fish. And we will also be looking for indications that the drilling reached its targeted zones. For completions, we'll be going over data for any possible problems: frac not taking enough fluid, frac taking too much fluid, screenouts. We will be simulating the production if re-entered and recompleted, possibly discern if the previous fracture job was sufficient. This is our milestone schedule for next semester.
For the scope of the hydraulic fracture simulation, we'll be using SteamPlan 3D. The frac design is going to follow the tenets of the constructal law. We're going to perform numerous iterations, changing various parameters to optimize flow rates. The outputs of the program are going to be inputted into a program written in Python so we can compute the economic aspects of each iteration of the fracture simulation. The schedule baseline and work breakdown structure include tasks for project completion and tasks developed and optimized for efficiency and quality control. Field data is going to be an input for comparison to validate the output, and the project and schedule and deliverables are discussed through this presentation. This is an example of the work breakdown structure. This is an example of the schedule baseline.
In case we face a change in management plan due to unexpected problems, the following steps are considered. First, a call for group meeting to discuss that change. Second, consult the project manager, Dr. Stephen Sears. Third, implement the change in a way that the future deliverables are not affected and the change is handled in a way that the final outcome is met successfully. Finally, an authorization from the project manager is required before any change is implemented. In case we face a difficulty to finish this project, a backup plan is considered, is to use Khazan 2 well as an injection well for miscible CO2 EOR.
All information pertaining to the project will be communicated in some way, and that communication will be based on rules. Hassan will communicate data findings from well logs and geological documents, as well as any information from Dr. Sears. Mike will communicate the operational report for the formation, as well as any information from Mr. Knowles. Jack will communicate fracturing data, as well as the cost, and Ahmed and Tyler will communicate the meeting dates, times, and places, and any tasks that need to be done or goals that need to be met. We will also communicate whether or not we're on track with the timeline and any updates we receive from our stakeholders. This information will be communicated through weekly meetings or in person, group text messages, phone calls, emails, and weekly agendas and minutes. Once again, Hassan will speak with Dr. Sears, Mike will speak with Mr. Knowles, and all new information pertaining to the project will be given to Ahmed or Tyler so that they can send out weekly updates through text or email, and so that Tyler can have the agendas and the minutes ready at each meeting with any new information. Any stakeholders in our project will receive bi-weekly updates from the group through in-person meetings, minutes, and any emails, and all 5 members of the group will receive the following documents weekly: updates through text or email, agendas, and minutes. Dr. Williams and Dr. Ratonwich will receive updates about the project through the project charter presentation, the progress report presentation, the final project plan presentation, and minutes and agendas submitted. All members of the group are expected to communicate any new information about the project to Tyler or Ahmed so that they can further communicate this information to the stakeholders in the project and to other members of the group. Failure to do so will result in a delay of the project and could eventually lead in project failure.
The procurement management plan discusses ideal procedures and management strategies. The procurement is approved by the Department of Petroleum Engineering, and some of the examples of the software that we need is Interactive Petrophysics and Stimplan 3D. Fortunately, they're both provided by the department, and we don't need any further costs to be able to have them.
Project Scope Management Plan is everybody's responsibility, but it will be headed by Ahmed Habib. Requests to change the scope may be brought forward by anyone, but the advisors will have the final say, and advisors will sign off on final deliverables.
The schedule management plan development to maximize output quality, and it also discusses members' responsibility and the sequence of operations that we're going to follow in order to successfully complete the project. The Gantt chart discusses how we're going to optimize our time to be able to complete the project. First, we're going to start with the petrophysical analysis of the well logs, and then we're going to design a fracture to be able to run a simulation model with and without a fracture, and come up with a flow rate that we're going to use in the economical analysis, and be able to determine whether it's economically feasible to re-enter the well or not. Hole conditions are going to be studied, and then we're going to write a recommendation whether to re-enter this well or not.
Quality will be assessed in multiple ways. The group will discuss deliverables, the advisors will review them. If they find them to be insufficient, the group will reevaluate. If they found them to be sufficient, they will proceed with the project.
Currently, our project anticipates no necessary costs, but we understand there's always a possibility to incur the costs. Dr. Sears has the authority to approve any incurred expenses for the project, and he will provide insight and suggestions as to the necessity of any potential costs. If there are any necessary expenditures, I will track and manage those costs, and those will be reported bi-weekly to Dr. Sears. Earned value calculations will be used to account for any cost deviations from the budget. Cost and schedule performance indexes will be reported monthly. Any variance above 20% will be deemed to be critical. We are currently working with the IT section to renew a license for Stimplan. This is the preferred program to use, and we believe that the license will be updated properly in time for us to run these programs.
Managing a risk is by appropriately approach the risk itself. The risk that we might face in this project are the following: insufficient data to make an informed decision, not getting responses needed to provide valuable insights, inability to meet given deadlines, unforeseen complications in the world that have not been previously noted, not having support needed to deliver this project with high quality. In case a risk is encountered in this project, the project manager is going to assign a specific risk manager to each risk. This table shows the risk, probability associated with it, the impact on this project, the action taken in case this risk happens, and the assigned risk manager.
The project will be staffed based on individual members' strengths. Ahmed Habib will be the project manager, Hassan Al-Hassan will be the well log analyst, Mike Giles will be in charge of operational reports. Tyler Castillo will set meeting dates and communicate between group members. And Jack Kagan will be in charge of the reservoir simulation.
Resources that are expected to last the entire length of the project include data provided by BP, information gathered from industry advisors, as well as Dr. Sears and Mr. Knowles, any minutes and agendas, the online LSU library database, team members, and our petroleum engineering textbooks. Resources expected to last during the spring semester include fracking lab simulations, the Petty Computer Lab for petrophysics and formation evaluation, and access to the PERT lab.
For the cost baseline, earned value metrics will be evaluated and presented to all recipients. CPI, used for sunk cost, will be expected to have a value greater than 1, indicating good economic performance. Likewise, TCPI, used for opportunity cost, is also expected to be greater than 1. For the quality baseline, industry representatives will advise us to ensure professional levels of quality. Presentations should be clear and concise without any major errors. All data should be clearly presented and annotated, and all project members, as project sponsor, and industry representatives should agree that the project meets professional standards of quality.
The next step is to start analyzing the well logs for key parameters for next semester, and then prepare a fracture design and study wellbore mechanical condition, and then run the simulation models to be able to have the economical analysis and decide whether to re-enter the well or not.